So I've got a question here, and it's asking me to find the parabola which creates the least volume when rotated about the x-axis and intersects the points 0, 0 and 2, 2. So let's just have a quick look at what that's asking. So we've got our points 0, 0 and 2, 2. And we want some parabola which just intersects those 2 points. So for example, we could have this one. And when it's rotated around the x-axis, that will create a 3-dimensional shape, like a cone or something like that. And we want the least volume that we can create with any parabola. So another parabola we could have could go even like this. That's also a possibility. And this is also a possibility. All of these parabolas all intersect points 0, 0 and 2, 2. So we want to find out a formula for that parabola. Now, first of all, we need to work out an equation for a line that goes from 0, 0 to 2, 2. Now, one such formula for that is we could write our y as x plus ax 2 minus x. So for all values of x from 0 to 2, that will give us our y. And what we want to give us our best parabola, we want to find this parameter a, because when we expand that out, we'll have y equals x plus 2ax minus ax squared. So that would be a parabola. That'd be a valid parabola. Okay, now which parabola is it going to be? Well, first of all, we need the formula when we rotate around the x-axis. So a volume of a cone rotated around the x-axis, that's going to give us our volume equals the integral from 0 to the highest point, which is 2, and that's pi times our y squared. And what we do is we now have to integrate that with regards to x, not y. So that's what we're interested in. Now we've got our y. We've got these two terms here which represent our y. So now all we can do is substitute in our y in this integral, and that's going to get us on our way. So v equals 0 to 2. Now the pi I can bring out front because that's just a constant multiple. And then our y squared, which is, I'm going to use this term here. So now I've got x plus ax 2 minus x all squared and dx. So that's our start of our integration. But what we want is the smallest volume. So when can we get the minimum? So we're interested in the minimum volume. But it's not in terms of x, we want it in terms of a. So we want the minimum of the volume in terms of a. So what we can do is now, to get our minimum value, we can take the derivative inside this integral with regards to a. So let's do that. So the minimum of the volume with regards to a equals the derivative of the volume with regards to a. So I'll give that a capital A. That equals the derivative of this with regards to a, and then we're going to set it to equal 0. So that equals pi 0 to 2. Now what's the derivative of this with regards to a? Well, we've got the term squared, so using the chain rule we can bring the 2 out front. So we've got 2 times x plus ax 2 minus x. So that will be all inside the brackets. And then with the chain rule, we have to take the derivative with regards to a of what's inside the brackets. Well, this term will disappear, and here we've got ax times 2 minus x. Well, with regards to a, we'll just be left with this bit here. So now we multiply all of this by x 2 minus x. Let's just make that a little bit clearer. 2 minus x and dx. Okay, let's get this bit off the board. Okay, and then we set this to 0. So hopefully then when we integrate, we'll be left with our a, the x will integrate out, and we're left with an a term set to 0, and hopefully we can solve to a. That's going to be our goal. Okay, let's do that. So now this equals pi with the integral from 0 to 2. Now to integrate this straight off, that's going to be a little bit awkward. So why don't we take this term here and distribute it, we've got what we've got in the brackets. Okay, so it's all times by 2, which is a constant multiple, so I'm going to bring that out to the front with the pi. And then I've got this term here, which I can distribute with this x. So x times all of this will just give me x squared 2 minus x. Okay, and now I've got this term, which I can also distribute. So now I'm going to add a, and then x2 minus x times x2 minus x, we just square both of those terms. So x squared 2 minus x squared, and then dx. And that all equals 0. Okay, right. Now, before I integrate, I probably need to distribute these x squareds and factor out all these brackets, or FOIL out all the brackets. So let's do that next. So then that equals 2 pi integral from 0 to 2. Right, this one's a bit more straightforward than this one, so let's go into that. So x squared and 2, and x squared and minus x. So that's going to give me 2x squared minus x cubed. And then this one here, I'm going to add, right, ax squared with this one. Well, let's just square this first. So this will give me 2 minus x squared will give me 4 minus 4x plus x squared. So that's what that term will be. And then multiply all this by x squared and a. So now I'm going to have 4 times ax squared. So 4ax squared. Minus 4x times this. So that's going to give me minus 4ax cubed. And then x squared times all of this. That's going to give me plus ax to the 4. And with regards to x, and set it to 0. Okay, right, now we're ready to integrate. So let's just go straight into it. So we've got 2 pi, and then integrating all of this with regards to x, this will become x cubed, then divided by 3, multiplied by 2, so that's 2x cubed over 3. X cubed, that's just x to the 4 over 4. This one is 4a x squared, but what I'm going to do is, as a is my goal, I'm going to factor out the a in this part of the integral. So I've got a, open bracket, so now take out the a and now just do 4x squared and integrate that. So now I'm going to have 4x cubed over 3. Then minus 4x cubed, that's going to give me minus 4x to the 4 over 4. So that's just minus x to the 4. And this one here, I've taken out the a, so x to the 4 integrates to x to the 5. So that's a plus x to the 5 over 5. And this all still equals 0. And this integral is calculated from 0 to 2. So 0 to 2. Okay, right, so wherever we see an x, we just make sure we've got a 2 in there. So then this equals 2 pi times 2 cubed is 8. 8 twos are 16, so 16 over 3 for this one. 2 to the 4 is 16. 16 over 4 is just 4. And then plus a times, well, 2x cubed here, we've got 4x cubed here, so that's now going to be 32 over 3. So that takes care of that one. This one we've got x to the 4 when we see when x is 2, so that's just going to give me 16, so minus 16. And then x to the 5 over 5, well, 2 to the 5 is 32, so that's plus 32 over 5. Okay, and then all of that equals 0. Okay, right, let's bring this up the top and see if we can calculate this a little bit more accurately and solve for our A. Okay, let's just simplify this off and see if we can find our A value. So what we can do is we could divide both sides by 2 pi. So that would get rid of my 2 pi. So then I'm left with 16 over 3 minus 4 plus A times 32 over 3 minus 16 plus 32 over 5 equals 0. Okay, right. So I've got two constants here, so let's make them in terms of something divided by 3 and get a value for that. Well, 4 over 4 is the same as 12 over 3. So 16 minus 12 is 4. So here I've just got 4 over 3. So that's the equivalent of what that one would be. Here I've got plus A. So common denominator here, 15. So let's do that. 5 3s are 15. So everything over 15. So I'll have to multiply this by 5. 5 times 32 is 160. Now this one over 15, I'll have to multiply that by 15. So 16 times 15 is 240. So minus 240. And then 3 with this one. So that's going to be 96 over 15. So I need to add 96. Okay. And this is all set to 0. Okay. Let's simplify this off even more. So here we've got 160 plus 96 is 256, minus 40, that gives me 16. So I've now got 4 over 3 plus A times 16 over 15 equals 0. Okay, so now we can solve for A. So let's bring the 4/3 onto the other side. So now I've got 16A over 15, let's write it like that, and that equals minus 4 over 3. Minus 4 over 3, if we put that with a denominator of 15, multiply everything by 5, I will now have, instead of that, I will have minus 20 over 15. Okay, now I can cancel out my 15s, and now I've got 16A equals minus 20. Okay, so now A will be minus 20 over 16, A is minus 5 over 4. Okay, so that's my parameter that I need for my solution for my y. So now my y will be x plus A is minus 4. So change this to a minus. So I now have minus 5 over 4 times x to minus x, which would simplify off to y equals x minus 5x over 4 to minus x, which equals x minus 10x over 4 minus 5x squared over 4. But that's 2 minuses, so that's a plus. Okay, now let's get some x's together. So if that's multiplied, put that as 4 over 4. I've now got 4x minus 10x, so that's going to be minus 6x, and I've got a 5x squared over 4. So now I've got y equals 5x squared over 4 minus 6x over 4. So that is going to be my parabola that I need for my minimum surface of revolution along my x-axis. So if I can draw that parabola up on there, that will appear something a little bit like that, where that point there is 2, 2, and that's my origin 0, 0. And that will give me my least volume of rotation around the x-axis. So I'm going to draw a graph of that and display it at the end of this video so you can see what that is. Okay, so now what we can do is, now we've got our parameter A, and we know that this is our parabola which will give us our least volume, what we can do is now calculate what that volume is. So let's clear this off the board and use our formula for the volume. Okay, so now let's use our formula for our volume. So the volume that we got at the beginning of this video was pi times the integral from 0 to 2 of y squared. So y squared dx. So this was our y, so let's plug that in. So now we get pi from 0 to 2 of 5x squared over 4 minus 3x over 2 squared dx. And that will give us the value of our volume. So let's square this inside term. So pi from 0 to 2. Now squaring this off. So 5x squared over 4, square that. So we'll have 25 over 16 x to the 4. So that would take care of that term squared. Now let's square this term, and then we'll end up now with a positive 9x squared over 4. So that's 3 over 2 squared, and then the x squared, that's 9 over 4. Okay, so now we need two lots of this one multiplied by this one. So 5 over 4 times 3 over 2, that's going to give us 15 over 8. So twice, that will give us 30 over 8. So minus 30 over 8. And then x squared times x is x cubed. Okay, and then that's all with regards to x. Okay, now let's just do a little simplification. 30 over 8 will give us 15 over 4. So that's 15 over 4. This will stay as it is, and this will stay as it is. Okay, so now we're ready to go straight into our integration. So now pi, and valued at 0 to 2. So this will be x to the 5, and then divided by the new power, which is 80. So that'll give us 25 over 80. Okay, we'll simplify that off in a minute. And then add 9 over 4, and then x cubed, and then 4 times 3 is 12. So x cubed, 4 times 3, that will now give me 12. And then here I've got 15x cubed, so minus 15 will be x to the 4, and then divide by the new power, that'll give me over 16. Okay, so evaluate this from 0 to 2. That's going to be our goal. Now before we do that, let's just simplify things off a little bit. This one is simplified enough. This one will just be 3/4. So that's 3/4. And 25 over 80, that will give us 5 over 16. Okay, so now let's plug in 2. Again, as we did before, when it's 0, it all disappears. There's no point even thinking about the 0. So let's calculate it at 2. So now we've got pi times, so 5 times x to the 5. So that's 5 times 2 to the power of 5, which is 32. And divide that by 16. That's our first evaluation. And then 3 times x cubed, so 3 times 2 cubed, so that's 3 times 8 over 4. And then this one, x to the 4, that 2 is 16. So those would just cancel out. So now I just do minus 15 times 16 over 16, which you know will cancel out. Okay, now what's that going to give us? So 5 times 32 over 16, that will cancel out, and that will give us a 2. So now that will give us 10. 3/8 or 24 divided by 4 will give us 6. And then minus 15 times 16 over 16, they will cancel out. So now we subtract 15. Okay, so very interestingly, we've got 16 minus 15 is 1, and then pi. So therefore, our volume, which is our minimum amount at this parameter, our volume just equals pi. So that's quite an interesting solution to that. When that rotates, the volume just gives us pi. Okay.